going to illustrate in this video clip is the simple proof that the square root of 2 is an irrational number. The proof is not terribly difficult, and it's been around a long time. It was certainly known 2,000 plus years ago to Archimedes, Pythagoras, and the other Greeks in that little circle for the following very simple reason. They knew that they could construct a triangle of sides 1, 1, and that means that the third side of the triangle was the square root of 2. Therefore, they knew that the square root of 2 existed. It was the length of this particular triangle. They could draw it in the sand. It was a number that was very, very real. The only difficulty was that they had the belief that any number at all could be expressed as a fraction of any two other numbers that already existed, any two integers. They held that there was no such number that could not be expressed as a ratio of two integers. And therefore, when they realized, and probably in the same fashion that we're about to realize here, that the square root of 2 could not be so expressed, they simply turned their world upside down. So let's establish that the square root of 2 cannot be expressed as an integer divided by another integer. First, let's assume that the square root of 2 can be expressed as one integer over another integer. One integer over another integer is a definition of a rational number. Numbers that cannot be expressed as one integer over another integer are held to be irrational. Not that they're crazy in any sense, they're just irrational. Let's assume that this is true, and we will show by assuming that this is true that you're led to contradiction. Therefore, the only thing you can do is throw away your assumption that this is true. The assumption will proceed by examining four possibilities. First, that P is an even number and Q is also an even number. Therefore, it is an even over an even. Or you can say that P is an odd number, while Q is an even number. Or you can say that P is an even number, while Q is an odd number. Or you can say that they're both odd. Now, one by one, we will show that all four of these possibilities, which exhaust all the possibilities, lead to contradiction. First, if we assume an even over an even, then any even number, P can be expressed as twice some other number, and if Q is an even number, it can also be expressed as twice some other number. Therefore, the 2's cancel, and you have reduced it down to m over m. If both of these continue to be even, you can continue such a reduction until finally you get a 1 in either the top or the bottom, and it's no longer an even over an even. So evens over even do not remain even over even, and they are gone. Next, let's examine an odd over an odd. If the square root of 2, if you assume that P is an odd number, and you assume that E is an even number, then if you square both sides, you will get that 2 is equal to an odd number squared over an even number squared. So let's examine a few properties of even number squared and odd number squared. First, an even number squared is equal to an even number times an even number. But an even number is twice some other number, and this also is twice some other number. So this is 4 times some other number. And if you take any number, no matter whether it's odd or even, and multiply it by 4, it's going to come out to be even. So even squared turns out to be an even number. So 2 is equal to odd squared over an even number. Now let's examine odd squared. What happens if you square an odd number? It's equal to an odd number times an odd number. But an odd number is an even number plus 1. So if you just FOIL this out, you get an even times an even, plus an even, plus another even, plus 1. Now we established a moment ago that an even times an even is an even. These are also evens, so you get an even plus 1, so you get an odd. So we established that the square of an odd number is always odd. So that means that 2 is equal to 2 is equal to an odd number over an even number. Now if you just cross multiply this, you get that twice an even number is equal to an odd number, but twice an even number is even. So you establish that even must equal odd, which certainly is a contradiction. So that's gone. So we've established that this also leads to not truth. Now let's assume even over odd. Square root of 2 is an even number over an odd number. Now an even number can be expressed as twice some other number, no matter what it is. And so the odd number remains odd, the square root of 2. So now we square both sides. And we get that 2 is equal to 4 times some number undesignated over odd squared. Now we divide both sides by 2 and produce that 1 equals 2 times any number whatsoever over odd squared. Now if we cross multiply, we get odd squared equals twice by any number whatsoever. And we've established that odd squared is an odd number, and any number whatsoever, if you double it, will turn out to be even. So we once again have odd equals even disallowed. So this one is also disallowed. So the only other remaining possibility is that the square root of 2 is equal to an odd number over an odd number. And this is perhaps the easiest one of all. We simply square both sides, and then we get 2 is equal to odd squared over odd squared. And we've already established that odd squared is odd, so we get 2 equals odd over odd. And again, cross multiply, 2 times odd equals odd, but 2 times odd is even. So once again, we have even equals odd, which disallows this also. So all 4 possibilities are disallowed, and then the only thing to conclude is that your assumption that the square root of 2 was equal to some integer divided by another integer cannot remain. So you have to then discard your assumption and declare that the square root of 2 can never be expressed as one integer divided by another integer. Therefore, the square root of 2 is not a rational number. So we introduce a concept of an irrational number. The square root of 2 is what we call an irrational number. We're very used to this now, and it does not cause us to get panicked. However, the Greeks had numerology so embedded in their culture and theology that when they discovered this themselves, the few people to whom knew it in the inner circle of the mathematicians at the time were sworn to secrecy, not to reveal it to the general public upon pain of death. And here now I'm revealing it to the general public.